but temperature-wise, I think it's a quite comfortable situation. A bit too hot, but never too cold, I would say. So exposure to sun, I don't think you need it.
And this is regarding the humidity.
So very humid, so in that sense it will be uncomfortable because it's just too humid.
Especially during the summer. This is a graph for the hourly radiation, which seems aligned with the previous graphs on radiation, with the lowest values being verified around June. And the summer months in the beginning and the end of the graph having higher values.
The only thing what you see here is that your direct radiation, even in January, February, are higher than your indirect radiation. So the red line is higher than your blue line. So in that sense, I'm not sure if your sunshine hour data, but it's of course a different source, are fully well reflecting your situation. I think it is a bit more sunlight or sunshine hours per month than the monthly data would indicate.
In relation to the amount of clouds?
Yeah.
Okay. And this is the comfort chart for each month? Yeah.
And that's what I mean. So on an average day in August, so that's your winter month kind of, you see that the orange line is quite okay. So somewhere on an average day, you will always feel comfortable during daytime. Nevertheless, there will be some days where you see it's too hot, it's even above 30 degrees. And some other days, it might be a bit below. So if it's around, if it's below this horizontal green line and it's daytime, then indeed you need direct sun exposure. But I think it's rather the mornings, for example, and then not the afternoons. But here, so the cloud indicates a bit that indeed some days it will be slightly uncomfortable in terms of having too cold, but that's really rare in your location.
And the comfort chart for summer months in January.
Too hot and too humid. So you need ventilation. It's clear.
Regarding the wind analysis, wind mostly blows from southwest to northeast, and we find peak values around the morning, after 7, and wind speeds peak at around 2 to 3 meters by second.
So for ventilation, it will be important to direct your openings to that direction, because is it common? You maybe have it on the next slide. It's constant over the whole year. I don't have it. So if you look at your, that could be important for you to have a look at the wind direction month by month, because especially in your summer months, you would need the wind to ventilate well and cool down. So your orientation of the building, I would put it in that direction so that you can capture the wind as much as you can.
So this is the readings done comparing the climate data, weather data, and the building itself, where I talk about the importance of having a central patio to allow for cross ventilation across the rooms, and how the external corridors create shadows not only for these corridors but also for the openings that are adjacent to the classrooms. And they don't use glazing for many reasons, also an economic thing, and the location isn't necessarily very accessible for these types of materials. So, but also the use of Venetian doors and shutters creates shade, but allows for ventilation at all times, even when they're closed. Thank you very much.
Thank you. Any questions? No? Okay, thank you very much. right, then we move a bit more upwards and we look just above the equator where we have two students, somebody from, two from Vietnam, one from Ho Chi Minh City and one from Hanoi. Who is who? Ho Chi Minh City and Hanoi? Yeah. Okay. Let's have a look. So where are we located? So we are located so here we have Ho Chi Minh City, and then just a bit higher up, so it's about 10 degrees higher, you have Hanoi, right? So what does it mean? We are now on the northern hemisphere, so now the sun should be, the highest radiation should be again in June, July, and the lowest in January and December. Let's have a look at the two data analysis of the month, or the monthly data analysis. So these are the two graphs that you have derived, which are very similar, quite similar. The only big difference is the sunshine hours, which seems quite to be different in the two contexts. It's a bit strange or difficult to assess the left one because you did not include any solar radiation. No, but you could leave the values which are automatically calculated in the file based on your latitude. I would keep them in. So one line you should keep in so that at least you have an idea of the maximum amount of radiation, because here you have indicated the real sunshine hours, but these seem to be as high as your maximum amount, which is strange, and it's always the same. It means it's always cloudy in your case, which I don't see here. So I assume something is wrong with the sunshine hours. It's not so logic. And then if you look here at the graph, the highest rain period is according to this graph, is from May till October. Yeah. But if I look here, it's the opposite. It seems that then you have the most direct sunshine hours. And here you have very little sunshine hours, where I don't see any rain over there. So either the explanation is that it's quite cloudy, but it doesn't rain, and so you still have low number of sunshine hours, or there is something wrong with the data. In this case, the only option that you have, if you have many sunshine hours, but you also have a lot of rain, you can only explain it when you have a heavy rainfall 1 hour a day, and the rest of the day it's dry but blue sky. That's the only reason when this combination is possible. But so I don't know, so you lived in Hanoi? What's the case actually, so in the months June to September?
Yeah, in fact, from the month June and September, there's a lot of rain. Yeah.
And is there a lot of clouds overall in the day, or is it just 1 hour crash and then the rest of the days?
I have some problem with collect the data from the rainfall. When I search in two websites and weather database and other website, I forget the name. We have a different data, so I choose the one in weather data, weather base, weather base. And in fact, I'm not sure about the cloud, but in June from September, there's a lot of rain come to my
but do you have
city.
The experience living over there, that's between June and September, you have a lot of blue sky or not? Or is it always gray and cloudy?
It's a lot of rain, but even they have we have a lot of sun into my city.
Okay.
Yeah.
So it could be that you just have every day 1 hour full rain and then the rest of the day is blue sky. That's possible, and then this could be explained.
Yeah. Yes.
But if not, there is kind of an inconsistency between the pattern of the rain and the pattern of your sunshine hours. This is strange. If we then look at the two comfort graphs, so both are, so the right graph, you only see the blue line because there was no data on minimum and maximum relative humidity, so that's why the lines are not drawn. So only average values are shown, while here the average values together with the min-maximum values are on the graph. So both of them are on the right-hand side of the comfort zone, which means hot and humid. While in Hanoi, it's a little bit colder in winter time, let's say, than in Ho Chi Minh City, which is even more warmer. But humidity-wise, Hanoi is even more humid, but both of them are clearly needing ventilation. If we then look at, so these are based on the monthly data. If we then look at the hourly data, so I first start with Ho Chi Minh City now, which is on this side. So here that's the averages for each month. So again, too humid, too warm. And then if we zoom in to 2 months, here we have January. So we see that although on an average day it's too humid and too warm, we see that some days it's actually comfortable, even it's too cold, while others it's even more extreme regarding temperature and humidity. So you do see a range. While the cloud is a bit more narrow in August, so the days are more similar, let's say. So here we have quite a diverse day pattern, while here the days are very similar. It's always the same thing, too warm and too humid for every day. If we then look at Hanoi, on the other hand, so this was the monthly data, these are the hourly data. So it's more or less the same, but here you couldn't see the difference between day and night, which you can now do see here. So we see that during daytime, either comfortable, too hot, or just okay, or just too cold, let's say, if you're in the shade, but as soon as you have a little bit of sun, it's okay. While nights, I think it's still fine because you have additional bed sheets on, so no need to heat at least. Ventilation is probably the only strategy needed. And looking at the two different months, it's a bit the similar pattern. So also here in January you have a larger cloud, so higher differences, larger differences between minimum and maximum temperatures over days. So one day it could be only 12 degrees, while other days it could be 25 or 26 degrees. So you do have quite a large range. While in August month it's always too humid and too warm any day. So it means there you need ventilation. It's impossible to have a thermal comfort without ventilation. Okay, that's to compare both. So very similar, I would say. The one a bit more extreme than the other, but a very similar situation. So I picked out one to present the case study. So it's you on Hanoi from who can present if you want. I will take the presentation for you. So mainly more of emphasize the case study, I would say, as we went through the analysis already, but it would be good if you could present your case study. Yes.
Good morning, everybody. My name is Theo from Hanoi, Vietnam, and my case study I choosing the apartment in Honda Street, Hanoi City. This is one of the first high-rise apartment in Hanoi, and when we I wrote this project, and when we after we designed this building, we learned a lot from developed country from Europe, and when we applied this design in Hanoi, after some months, some years, when people living in this area, and we have a lot of comment that this block is sometimes is not suitable with the way people in Hanoi living. Depend on the it's not suitable with climate change. Climate in Hanoi, and that's why I choose this study and apply some climate analysis to review our design.
And what were the complaints then? What was the problem?
The problem about it's not suitable with the climate in Hanoi compared to the traditional housing style. And for example, it's quite hot and weird, and the resident, the people living in this apartment is a lot of electric for cooling. Yeah.
Maybe just a recommendation for all of you: when you put your plans in the paper, also put the orientation of the building, because it's not clear to me where the north, east, south, just to understand better.
Yeah, in the southwest of Hanoi City.
But the north, is north up or is north that direction? So how is your building oriented?
In the southwest of Hanoi City. Yeah.
No, not your building compared to the city, but here, where is the north? If I look at your plan, where is the north orientation?
Up in the north in.
Up, okay.
In north is up. Yeah.
Okay, but so add that on your plan when you put it in your paper. That it's clear where north is.
Here is the location of this building, and I choose some data about the climate value. But in fact, when I search our sun in weather based, there's no data for for this, and I search in other website, and I put to the table, and so I think I had different from the data between the climate data, so we have a little bit conflict. In fact, in Hanoi, there's a lot of rain during the June and September. Even though we still have high temperature during this summer, and compared to Ho Chi Minh City in the south of Vietnam, the weather in Hanoi is more complicated. We experience very hot day in the summer, and even we have a very cold day in the winter. And so when we design the building to that suitable for the winter and the summer, is challenging.
But if you say you have cold, maybe we should wait for hourly later. But if I look at that, I wouldn't say I have very cold winters. It's still 20 degrees more or less in the afternoon.
Sometimes we experience under the 10 degree in the winter, but the feeling of the people in under the 10 degree in the summer is very cold. It's, when I travel to Europe or in Korea, I can wear so like this, but I can wear this cold. But in Hanoi, no, because it's very cold in.
Because it's cold and humid, probably.
Yes,
And
right.
there's the moisture in the air, so even 20 degrees in Vietnam is much colder
Much more
when
cold.
20 when I came
Compared
here.
to sometimes when I live in level, I can build the degrees about 3 degrees. But when I tell about this to my colleague in Vietnam, so you experience 3 degree in level, yeah. But in Vietnam we cannot. Yeah, it's so challenging for builders to create design the building in Hanoi. And about the comfort zone, so in fact,
yeah, you can skip that one.
Yeah. In fact, I don't understand much about this comfort zone and to apply to compare to our design. Yeah. The degree in Hanoi City, the month.
So here you can see that you have some days, but not so many. That in January, indeed, it's -10. Well, it's under 10 degrees. So we have 9 degrees or 8 degrees.
Yeah.
But it's quite exceptional.
Yeah. But in fact, in my city now, we feel that the hot day in the city is the summer is longer than and the temperature it tends to hotter than some years before. It's because of, I think it's because of climate change, but also because the way we designed building in Hanoi, there's a lot of concrete and lack of greenery, and so I think we face challenging with cooling in building. Even the temperature, the analysis is this,
but these temperatures are indeed from weather stations, typically. So it means it's an open field, so this is measured. While if you would do the same measurements in the city center, probably it will be all higher because you have an urban heat island effect. But we'll discuss that from next week onwards. We'll talk about the difference between weather station data and indeed urban heat islands, which indeed, if you have a lot of concrete, not a lot of green, not a lot of water, temperatures are much higher. But that we will discuss from next week.
About the air humidity, and you can see that we are in my city, the humidity is quite high, especially in the spring from October to December. Sometimes it's extend to the January of the next year. We experience high humidity when we live in the ground floor, the first floor, and you can see the floor, and so every wall and everything is wet, and it's
inside the building.
Inside the building, and it's challenging for us to design the high-rise building, and we have no passive design for this problem.
So, but the humidity comes from the air, so you have humidity in the air, you have water vapor in the air. If the walls become wet, it's because
floor and every table is wet.
It's because you have condensation. So the water vapor in the air condensates to water. That's the reason why everything is wet. And there are two strategies. Either you reduce the moisture in the air. It means, especially inside the buildings, you always put ventilation on when you take a shower or when you work in the kitchen or whatever. So as soon as you produce a lot of moisture, you need to put the ventilation system on. The big issue is that if it's outside, also a high level of humidity, it's really hard to get the moisture level down. And then the only thing what you can do to avoid condensation is to raise the temperature. Because the higher the temperature, the more moisture the air can carry and the less condensation you will have. But of course it means if it's already a quite high temperature in the house, your comfort level will not improve by raising the temperature. But that's the only thing, especially on cold days, to avoid condensation. What you have to do is either remove the moisture, but if you can't do that because outside it is as moisturous as inside, then raising the temperature in the house is the only option.
Yeah. Thank you for the suggestion. Yeah, in fact, in our building, so each family they bought some machines to reduce the humidity in the but they had the use the machine is not plastic design, so about radiation, solar radiation. You can see that in my city, the radiation is direct radiation in is quite high, and there's no gap between the every direction and every diffuse radiation.
Yeah, but so if I look at your graph here on the left top, it seems that in January, February you have a lot of clouds because your indirect radiation is higher than your direct radiation, which was not reflected in your sunshine hours. So there's something there. No, that was reflected. I think you had little sunshine hours in January, February, blue color. If you go back to your, can you go back to your slide with the sunshine hours just to remember the correct situation? So that's how you can compare if it makes sense, or if you have wrong data. Because especially when you say I'm doubting on my sunshine hours, because so here you see
sunshine hours. Yes, I really I see in I collect in other websites.
Yeah, I know. But so you collected it at that point, and that's what you have. What you need to do in your paper is clearly state where the data are coming from. So if you combine two data sources, mention it at that time. But when you then analyze your hourly data, and you, based on the hourly data, you doubt if this is correct, then mention it, that there's a conflict or that it doesn't seem logic. But it does seem logic that here you see in January, February, March, according to this data, you have a lot of clouds, so you have more indirect radiation, and you have little direct radiation, which I think was well reflected in your hourly data. And in June and July, you have a little indirect radiation and mostly blue sky, which conflicts a bit with the rain pattern, but I think the rain for you is at really 2 hours full rain, and the other hours are quite clear sky. I think that could explain the pattern. And if you now go back to your radiation graph, you indeed see here, so in January, February, more indirect, so that's logic. And then it should be half, more or less. So I think your graphs were correct, but so the rain pattern, I think that's the only explanation I have then. That you have either a few days in a month that it's really raining a lot and the others are blue sky, or it's every morning rain, and then the afternoon is blue sky. That's also an option.
Yeah, okay. In fact, in January and to March, we have not had much blue sky, and we have a small range. Small range in. That comfort.
So indeed, some days are really cold. So it's not only the right-hand side which is cold, but it's even the left-hand side of the whole cloud, which shows that some days it's only 10 degrees. So there you need heating. Heating or direct sun exposure. So you should capture a lot of sunlight through the windows.
In general, we need a heating system. In the August, with the comfort zones is about 20 or 30 degrees, and we have a lot of day that about comfort zones.
All days, huh? There's nothing in the comfort zone.
Yes, comfort zones. For the winter, we the winter director in the summers is we experience the from the north east director.
In winter, northeast, yeah.
Yeah, and for the summer is southwest.
I see southeast here on the graph. So if I look at May, June, July, August, it's all southeast, I would say.
Yeah, southeast. Can the lesson climate council design when we reviewed so I think some suitable design that we have a balcony so it's have to natural ventilation and we reduce the direct sunshine into the apartment, but in fact is a part of apartment is not for whole the building. We have no solution for all the building. So it's some rooms in the building that the balcony can have the direct sunshine into the apartment, but some other rooms in the apartment, the sun can go direct to the sun and heat the room, the humidity in the room. And so the unsuitable design that we rely that we use a lot of glass window and is made to the sun can come to heat the apartment and it lead to cooling is challenges to the building.
I had one question on this slide. So the last bullet point on your climate characteristics is southwest monsoon winds, which I didn't see on your previous slide. It seemed to be southeast. Where did you get this information from? Is it your experience or is it the wrong reading of the charts?
Yeah, in fact, there's the sound. I don't know why when the table is southeast, but in my country, the wind, the direct wind in the summer is southwest,
Okay.
and we when we use the passive design, we always focus on the southwest to gain the natural wind into the apartment. Yeah.
So it's important that you write it down in your paper then, that okay, although the graphs show southeast, that from your experience is wrong. So probably it has to do with the location of the
in our experience, we always choose the southwest. The good direction for the apartment.
But so you can understand as well the difficulty of your climate context and with this kind of apartment buildings is that you need heating in summer, passive heat gains, but you need cooling in winter. Opposite, you need heating in winter and cooling in summer. So you hear this design really invest in large window areas for the heat gains,
Yes.
but actually it's problematic in summertime. So you should shut it down by shading devices, move those shading devices, is the only solution I think you have here. Move those shading devices that still lets the wind penetrate.
Yeah.
So definition, louvers or whatever, something like that you will. Okay, thank you. All right, let's move on to the next. So then we have two students looking at a bit higher up, 20 to 40 degrees. It's in Iran and in Turkey. Who are the students? You are from?
Turkey.
Turkey? And you are then from Iran. All right, let's have a look. So 38 and 39 degrees, so nearly the same latitude. And here you see it on the graph. So it's hardly any difference in latitude. So quite similar regarding the path of the sun, let's say. It doesn't mean that the weather is completely identical, of course. Here you see the two graphs. Quite different in sunshine hours, while if you look at the blue line is the estimated one, it's quite similar, and that has to do with the latitude. So this only changes when the latitude changes. But these are the real data then, I assume it was. So it means if these are the real data, this should quite well reflect the sunshine hours, which are indicated in the purple here, which is quite different. So I'm not sure if it's correct that in Turkey you have less cloudy days in summertime and more cloudy days in wintertime. Is that correct?
Less in summer, yes.
Yes, yeah, okay, then it's well reflected. While in your case in Iran, it means you don't have a lot of cloudy days. It's always quite sunny. Mostly cloudy, then it means there's something wrong with the number of sunshine hours. It's too high now. Then if you look at the temperature range, it's quite similar, although here you have a lower difference or a smaller difference between minimum and maximum on average, not the extremes, but on average. While here the range is quite high. So here you see a larger difference between night temperature and daytime temperature. So here I would remove the curve that you don't need to make sure that for radiation you only, oh sorry, I was too quick, that you only have one curve because it's a bit strange to have two. So if you have the real data, for me it's fine to use the real data. If you doubt the real data, then take the estimated ones. Depends a bit on the source, how trustworthy they are. And here we see the comfort zone based on the monthly data. So here we see the pattern of the days is quite a similar direction. It goes a bit more steeper if we go in summertime. So it means that a min-max temperature difference is higher in summertime than in wintertime. So there the range between min-max is lower, which is logic because you have less sun. So it's okay, it's normal, but it's not always. So the further away we go from the equator, let me tell it like that, the further you go away from the equator, the more differences you have between day and night temperature. So it's logic, and especially in summertime, there's also a larger difference between winter and summertime. So the closer we are to the equator, the more stable it is. Over the year-long path, there is not such a big difference between winter and summertime. While here, the further we go up, we will see that the differences is becoming larger, which means you have more sunshine hours in summertime compared to wintertime, so there are larger differences, which means that the steepness of these change over the year. While if you're closer to the equator, it's more the same angle over the whole year. Similar here, but here are some strange things. I'll come back to that. So here it's really steep, which is kind of impossible. Let's come back to that later. I always put also the altitude. I didn't say anything about that in the previous, but I also put it there because that could also sometimes explain why temperatures are different, even if it's on the same latitude. But here it's not an extreme difference in altitude, so that would not explain if there would be a difference. But so it's always important to also have the altitude as information to understand or check if you or look critically at the analysis. Then, if we look first at Iran, what we see here is going from monthly data to the hourly data, we see a similar trend. So I think these are quite aligned. There is not a big discrepancy, so I think that's fine. And if you then look at the 2 months again, so here you see January and here you see August. We see January, although there's a large cloud, so there are many different days, we still see that all of them are uncomfortable. So it's too cold, we need heating, or we need at least as much as we can have passive solar gains. While in summertime, there are days that it's quite comfortable, but especially on the hottest hour in the day, it will be too hot. And actually we're on the dry side now, so it's completely different than the previous presentations in Vietnam where we were too hot as well, but too humid. Here you see it's dry, so it's dry and warm, which means we need different strategies to have thermal comfort or achieve thermal comfort. The lower bond, so the right-hand side, these are typically night temperatures, so in summer you don't need heating, although at first glance you would interpret as I need heating also in August some days. That's not true, because that's typically during the night, and then we cover ourselves more than just with the summer glow. If you look at Turkey then, on the same graph, here you see that something was wrong here with these vertical lines. So here you see that the direction actually is always like that. So there's something wrong with the data here. So especially the humidity is identical, doesn't change, while there is a big temperature change. Something is wrong there. So I think that needs to be checked. If we then look at the 2 months, so here again it's a bit similar. Uncomfortable in winter time, quite comfortable in summertime, but there are still some days where it's too hot and that you need either protect yourself against the sun for sure, because this is in the shade. So even if it's comfortable in the shade, as soon as you have a little bit more of radiation, so when you're in the sun, in the summertime there, this comfort zone goes down. So it means then it's too hot for you. So it means you will need shading anyhow to feel comfortable. All right, then one presentation again. Let me open your presentation. It's a nice looking. Well, for me it was. I've never been there, so it was quite impressive to see as you have this mountain range, and then the city really developed just in front of it, kind of. So yeah. And remember, so we have a hot, dry climate now, so completely something else, and a hot, wet climate, or humid climate we had before. So the strategies are completely different now.
Okay, good morning, I'm Mahla. So the case study I chose it in my hometown, Tabriz. The village name is Kandawan. This village is behave like houses that carved into mountains, and there is a conical shape that has which this structure named cairns. So this it has a local material, and these cairns provide thermal insulation by absorbing sunlight during the day and releasing it at night. Also, in terms of orientation, it's in the way that prevents them from making a shadow for each other. Also, you can see from plants that because of that thickness of material that works, it's because it needs more heating in this climate. It has a role of insulation also. So in terms of monthly data, we see that in May, June, July we have the most radiation, and on the other hand, these months has the less rain in this month.
And humidity very low, huh?
Yeah.
Very low humidity.
So it's a dry climate. And comfort zone, as it seems, most of the months are not in the comfort zone. So just a few months in summer, we see that thermal comfort. In terms of temperature, it fluctuates between minus 15 degrees Celsius and 38, and the highest is in July.
Yep. So here we see that the farther we go up, so the latitude is increasing. We see that the yearly difference in temperature is also increasing. So a larger difference between winter and summertime.
In terms of humidity, humidity in winter is more significant than in summer, but overall it's not really good. Solar radiation, as it's seen, direct radiation is lower than diffuse radiation, so it means that we have mostly cloudy sky.
Yeah, something strange on your graph, some of it might have it as well, is that you see on the, not the blue ones on the right, and I'm looking at the right first, so the blue is clearly an hourly value curve, while if you look at the red and the green one, it's not fluctuating day by or hour by hour. It's like a rigid line, which you also see on the blue dark line on the left figure. So maybe I can show a different. So normally you should have a graph like this. As a graph, normally you have hourly values, do you see? So every hour or every day, these are daily averages, every day you have another value, which typically means you have here hourly values, and from the hourly values, daily averages are calculated in an Excel file, and then you have one value per month for the monthly averages. While in your case, if we now look at your graphs, it's different, you see? So these monthly data are fine, so you have 1 dot per month, but as you look at the daily averages, which is the dark blue one, so you have one with the daily averages. Do you see my arrow? No. Ah, yeah, you see it. Wait, but I can also show it like this. So these are the monthly. And every month has one value, that's fine, it's as identical as the previous one, also on the purple line and on the red line, but the blue line, which are the daily averages, should have actually 31 values, different values per month, or 30 values in 30 days, which is now not the case here. You see actually these lines. The same here, so normally these should be hourly values, which is now not the case. So that's just because you didn't have the data, and in the TMY file they just added these data to have one single value. But that's the reason why you don't see it. Yeah. So it's kind of a data gap that they filled by the same value if they, instead of hourly. So they didn't have hourly values, so they had to make a different date.
Thermal comfort, the months June, July, August, and September are the months that in comfort zone, and other months need more heating. In in the winter month, as seen, hourly values are more diffuse, so it means that it's lower comfort. On the other hand, in the summer, its hourly values are more consistent, so it means that we have greater thermal comfort.
Yeah, but only be careful. The green zone comfort zone is only in the shade. Huh? So it means as soon as you are outside in the sun, you will feel too hot. Huh? So it's only when you're in the shade, it's comfortable, but not always. Huh? So even in the shade, it's sometimes too hot and always. Huh? So the only thing what you can do then is try to lower the temperature. That's what you did. So that's why you built in the earth to make sure you have a more stable temperatures throughout the year. Meaning in winter time it will be less cold than you saw on the graph, and in summertime the temperatures are lower because earth heats up slower and cools down slower than air because the mass is different. So that's why you have a more stable temperature. If you would measure the temperature in the dwellings, even if you don't use it, you will see that actually the temperatures are lower than outside in summer, and in winter they're higher than winter. So that's the basic strategy you used to get in your comfort zone.
Wind analysis, as you see, there is wind direction in many directions, but most is on northeast. The wind speed is generally slow, and the windiest month is July. What we can do in climate conscious design, different things, but for materials that we can use the materials that are thermal insulation, like brick and stone that we.
But what do you mean with thermal insulation then? You mean materials that protect
cold measure.
Yeah, but there are two different things because bricks and stone are actually not thermal insulation materials. Thermal insulation materials are like rock wool, stone wool or glass wool or polyurethane with a low lambda value. But these materials are good for mass, so it's a good thermal mass, which is something else than thermal insulation. So I think either you are here mixing up two concepts. But using thermal mass and then bricks and stone are good. Indeed, you control the heat by having a more stable temperature, lower in summer and higher in winter, which is something else than thermal insulation. But I think you refer to thermal mass here. So really having this,
and we also can do space design by making north windows with shading for summer and some courtyards for ventilation. Thermal system, which is very important to heat for winter, and building orientation, which we also see in the case study, is important to maximize the sun. We also can use our renewable energy like solar panels, and also green spaces. And in terms of urban design, we can use natural surfaces to enhance airflow and block that cold winds.
and so with natural surfaces you mean natural like mountains or whatever?
Yeah.
Surfaces, I thought you meant like how the finishing would be of elements, but as a surface for me it's rather finishing, but that's not what you mean. You really mean the objects, natural objects actually. Okay, any questions?
I have a question.
Yeah, go ahead.
I chose that case study, but I think we need it's what should I say? I think think it will be difficult to collect data of that, and it's not.
I would keep it like this. I think it's a nice case study. Let's see for the cost how we will do it. We'll
Yeah,
try to solve
I-
the problem. Don't worry, I wouldn't change the case now.
Okay.
You're welcome. Then we go even a bit more higher up, where we have 3 students, somebody from Montreal in Canada, who is that? Noir. Then we have Italy, Turin on the back, and Ljubljana in Slovenia. Okay, let's have a look where we are. So the first is on the left, where we see, so that's the first in Canada. Then we have Europe, Italy. And then we have a bit more to the right, Ljubljana. So it's very similar latitude again, 45, 45, and 46 degrees. If we look at the 3 climatic analysis, then we see here something strange happening. So for Canada, I'm doubting if these data are correct. It's unclear to me. And the radiation is lacking. Well, you could at least include still your estimated radiation to have an idea of what's happening. And then here we have 2 lines where again I would delete one, either the estimated one or the calculated one, depending on which you want to show. But 1 line is sufficient, as we already have the 2 lines or the 2 data here. I think it's fine to have 1. If we then look at the temperature curves, so here we have quite large differences between extremes at least, which is larger than the others and which is lowest here. So the differentiation in days, and that we will probably see in the clouds, will be based on hourly data, will be larger. So normally you should see a larger cloud here than we have there. But overall, the temperature range is more or less identical. So if you look especially at the mean temperature, here we have the coldest ones, so the coldest winters are here. While here we are above 0, we start above 0 and we end up till 20 degrees, a bit higher, and it's the same here. So these are very similar, while here it's a bit more extreme in winter time. Say. So that's the big difference between the 2. But for all, you need heating in winter, typically. And summers might be comfortable, but sometimes it's too hot and you need cooling strategies at least. Alright, here is something strange ongoing in Ljubljana. I'm not sure what's happening, but it's impossible that suddenly your, so this is the, wait, let me check. So you have 3 curves. I think this is the minimum, the maximum, and the average, I think, but this one cannot cross up, so there's something wrong there. You need to check. I think you must have input something wrong there, but they cannot cross each other. They should always be parallel. Or the mean should at least be between the minimum and the maximum in all months. These are then the comfort charts, so we see always quite cold in winter time, reaching up to comfort in summertime, not always, but at least here you see first idea. Here something strange is ongoing with your data, so that's not possible that you have a combination of the lowest relative humidity with the lowest temperature cannot be combined. So I think you there gave an opposite entry to check that. Then let's have a look at the hourly values. So first for Canada, I think it's more or less a similar picture, hourly data and monthly data, so that seems consistent. If we then look at the 2 months, January on top and August below, we see again we have a large spread. So here we see we have a very large clouds, both in terms of humidity and in terms of temperature. So it means you have a large variation over the month. of January. But whatever the variation is, it's always too cold. So passive strategies are catching as much solar radiation as you can in winter time to reduce your heating demand. But you will need heating anyhow. While in the summer months, it's quite comfortable for many days. It will hardly be too hot. If it would be too hot, a slight breeze would be sufficient. While there might be some mornings at least where it's too cold and where you will need either additional heating or you can solve it with passive gains. Then I only took, because for Italy it was quite similar, I only included here Ljubljana, where we have this strange pattern, and which indeed is not visible in your hourly values. That confirms that there is something wrong inputted there. But overall, I think what we can learn from here, all months are too cold, except for some summer months, where probably at least some days it will be comfortable enough. And if we then look at the 2 months, indeed, winter months, it's always too cold. So passive gains are important, but still then you will need heating. And here we see some days it's comfortable, even too hot sometimes. And you need some ventilation or some wind at least, or a fan or whatever, but some air movement. While some days it might even be a bit too cold, and where you need the sun really. If you would be in a shade in summer clothes, it's too cold, so you need some passive heating gains to feel comfortable. Okay, then I took Canada as a case study.
Good morning, everyone. So my name is V, and I'd like to present about the apartment in Montreal, Canada. It's called Geoda Apartment. Sorry if my pronunciation is incorrect. So it's located in Montreal, Canada, which experience extreme weather. Extreme weather from ranging from winter to very hot summer, and it was constructed in 2017. This is a contemporary residential project inspired by the concept of a geode. So that's why the building has a mineral mass, and the interior is covered with crystal-like material, which is in this case a metallic tile. So the key features that I found in this case study is the abundant.
What did you say? A metallic tile? No.
Yeah, I think it's metallic tile. This.
Wait there. What can you indicate on the picture? What you mean?
The
brick.
Yeah, the brick. The brick.
The brick is not metallic.
Yeah, no, I mean the.
entrance.
I think the.
In the courtyards. Yeah, the triangles.
Yeah,
that's
sorry.
Yeah, okay. Okay, sorry.
The abundant natural light, energy-efficient materials, and the use of thermal mass for temperature regulation that ensure both comfort and sustainability. So, so the buildings design really try to leverage the natural sunlight, ventilation and vegetation so that it can create a environmental responsive design that enhance thermal comfort and improve the air quality of the interior. So in terms of the monthly, the climate data for the monthly values, Montreal typically enjoys the highest number of sunny days in summer from May to August, and fewer sunny days in winter, particularly in December and January. So the solar radiation levels may vary throughout the year, peaking during the summer months. So about the humidity, the area has a humid continental climate with cold and snowy winter averaging around -10 degrees and warm summer averaging about 28 degrees or even higher. So the differences between them would be around like up to 20 degrees. About the humidity, summer months experience higher humidity.
With higher humidity, then you mean the absolute humidity, so more rainfall, right? Because if you look at the relative humidity, it's lower in the summer months, and that's because the temperature is higher. Right? So the absolute humidity, indeed, is higher in the summer months, but the relative humidity is lower because of the higher temperature.
This is the thermal comfort monthly values. The temperature data, hourly data.
Yeah, and high fluctuations. So I think you have a large span, even within 1 month, you see differences from depths of 20 degrees. So it's quite high. So I think especially in summer, what would be a strategy, because in daytime it can be way too hot, 30 degrees, not always, but it can go up to 30 degrees, while at night it's always 10 degrees lower at minimum, even sometimes 20 degrees lower than daytime, so you need night ventilation, night cooling. I think it's a good strategy in summertime. So cool down your building at night so that it can cool down fully, and then the next day you start at a lower temperature, it increases by the end of the day, and then you cool again at night, and then it goes down again. So I think because of this difference between day and night, I think night cooling is a good strategy.
And the yearly humidity. So from this graph, we can see that the relative humidity is quite high.
Yeah, and this gives a different picture than we've shown before, I think, on monthly data. So here it's quite stable. If you look at the monthly data, one before, another one back here, you saw, if you look at the average, so the black line with the yellow triangles, you see a very high relative humidity in winter time and about 70 in June, July, while if you go to the hourly data, it seems more stable over the year. So here you see it's always around the 70s. So I'm not so sure if your monthly relative humidity data are correct or not, but it's just something to keep in mind that probably this is a more correct picture.
Yeah. And with the solar radiation, so during summer, the city experienced a higher level of radiation, and it's and the lowest during the winter because less sun daylight hour and more cloud.
It reflects what you said before, so it's really too cold. Here is also heating and solar radiation are the strategies I would say. And here you don't need heating, clearly not. I think what you need is either direct solar radiation in the days that it's a bit too cold, but I think 90% of the days it's comfortable. That's indeed what you experience in summertime in your location?
I haven't visited.
I haven't been there. So why did you choose this case study then?
I think it's just because I think Canada has a very extreme weather.
Okay.
Yeah. And the wind analysis. So the predominant wind directions vary throughout the year, but the main wind direction are from the west, south or southwest direction. And the key takeaway from this case study is in terms of material for durability, I think that using brick to absorb heat, and then they store the heat and radiate it at night, can keep indoor spaces warm during winter.
I'm not sure what you mean with keep indoor spaces warm in winter. How do you see that? By
I think the brick can absorb the heat from the daylight, from like the sunlight during the day, and then radiate it back in the room during winter.
I'm not sure what you mean during winter, because it's not like that you can absorb heat in summertime and store it until winter time, and that's impossible.
During the night.
Yeah, okay. So that you can do. So if you say during daytime, 2 o'clock in the afternoon, we have a lot of sun, and we store it so it's released a few hours later when people typically come home, that would function. But it's just a couple of hours. It's never a whole season that you can. Yeah.
And the building's airtight construction minimizes air leaks that help retain heat during winter. Advanced glazing technologies, so they use low emissivity glass. It helps reflect heat back into the room during winter while blocking solid heat during summer. And the last is natural ventilation. Incorporating interior courtyards for cross ventilation and daylight accessibility to improve indoor air quality.
How do you see these courtyards and natural ventilation as a strategy to reduce energy consumption for heating? I don't follow why it would reduce your heating demand.
And I must have mistaken it. It's also
I think cooling, yes, and daylight. I can imagine it's just the energy consumption in winter because you need less artificial lighting, but your heating demands will not be reduced by cross ventilation or natural ventilation. But I think it's the opposite. We do ventilate in winter time because of air quality, but it has a negative effect on the heating demands. Typically, your heating demand goes up when you ventilate because of the outdoor temperature is lower. And I note just maybe one more remark, because you have an airtight envelope, you have advanced glazing technologies, so I assume the building is insulated as well. So behind this brick, you typically have an insulation layer. I can imagine it's an insulated building, thermally insulated building. But then it's important to understand that the thermal mass that you need, so your bricks, if these are outside your insulation level, it will not help in storing heat because it's outside your insulation layer. So only the hard materials, or the heavy materials inside the building, so within this thermal layer, insulation layer, will help in storing heat and releasing it. But everything outside your insulation level doesn't do anything anymore. So then you cut kind of the heat stream to the inside, so it doesn't work anymore. So it only is valid, this heat capacity and thermal capacity only works, so absorbing heat and releasing it, storing and releasing it, only helps for non-insulated buildings when you have full walls in massive materials, or only when you have glass and that the sun can penetrate through your window, and then you have a lot of thermal mass inside capturing the heat. Then it works. So everything, the facade doesn't work anymore as storing heat when there's an insulation layer behind. Just that you're aware that it doesn't work anymore. All right. Any other questions or remarks? Thank you. And then we go to the final set of locations. So we have Brussels, then we have Russia, St. Petersburg, who are the students. Okay. So where are we? There is, well, in Antwerp actually, but we took here Brussels as a climate data because we don't have it for Antwerp. And then there we have a bit higher even, so it's about 10 degrees higher, so it will be colder over there. We have Russia. These are the two temperature profiles and climate profiles. So here we have Belgium, which you've seen before, so I will not discuss in detail, but that's a temperate climate, let's say, going from freezing up to 18 degrees. While here we see in Russia, where we have even higher latitude, that we have, the altitude is more or less the same, we see that we have extremer winters, so the winters will be even more cold than we have here. And then we see in summertime, here it can still be quite hot, but that's on extreme days. On an average day, we're rather here, so up to 20 degrees. That's meaning that's an average day is the same day. Let's look at the hourly data. It could be 10, and then another one is a bit higher, so it's an average. It's not every day that it's 20 degrees. But so a bit milder here, less difference between winter and summer. The more we go up, the more extreme the two seasons become, or the different the two seasons become. And you also see that here. So this is a lower latitude, which means the maximum sunshine hours difference is less than when you go more up. So the higher, the more north you go, the higher differences you have in theory. There are no clouds between winter and summertime. And then if you look at the real sunshine hours, taking into account the clouding as well, then we of course have the same pattern. But here you have less, so the days are shorter, meaning that also the number of sunshine hours are smaller, so kind of 0 sunshine hours on average, while having 1 hour in February up to, I think it's 9 hours or so in summertime. While here, the difference between the two seasons is lower, meaning that you still have a number of sunshine hours on an average day in January. So that's the difference between the two. Then looking at, so I will not discuss Brussels, as I already did that in the previous lessons. Let's have a look at Russia, where we see that it's indeed below the comfort zone, the full year. So heating is important. The only strategy we can hence use is having passive solar gates. So the windows, the design of the windows will be important. Here you see the hourly data instead of the monthly data, which shows the same pattern, so everything is below comfort. If we then look at the 2 months more in detail, this is the winter months, so as much solar gains as possible is a strategy over there. While here some days might be comfortable in the shade, but most of the days in the shade you're not feeling comfortable, so exposing yourself to direct sunlight or direct sun radiation is important. That's the main strategy. So it means the orientation of the building will probably be important, and the window area will be important. Alright, then I took the presentation of Brussels as case study.
Hello everyone, my name is Lily, and I will be presenting the monthly and hourly climate data for, well, the monthly data will be for Antwerp and then the hourly data will be for Brussels. So first, my case study, I decided to take the case study of my own home, where I live in a small town in Koningsoord in the province of Antwerp. And this is a neoclassical country house, a detached house. And I chose this case study because it's actually a quite old building. It's built in 1878, back when the techniques that we have today to ventilate the buildings and to heat and cool the buildings didn't exist yet. However, they did take into account the thermal comfort in the design of this building. Also, the house will be renovated very soon, so I thought it might be interesting to already make an analysis on which aspects of thermal comfort have already been taken into account and which should be taken into account when the building is renewed. The house is cube-shaped, so very compact design, and it is made of brick. Here on the right-hand side, you can also see a cross-section of the house.
So the cube shape is already an advantage because it means that you have less area where heat can be lost compared to the volume that you are heating up. So that's, I think, an advantage of that kind of building. I'm wondering on the orientation, so the map on top, the north is up, I can imagine. So it means what we see, the front facade is facing south then, right?
You can see orientation here. So the north is actually, here what you see on top is the facade, so the front.
Okay, so north, east,
so here,
southwest.
The north is on that side.
Oh, okay.
Yeah. So here we have the hand-drawn ground plans. A few things have changed, such as the fact that the continuous passing that you see from the front door to the back door has now been closed off with a wall, but the main aspects are still the same. So here again you see the very square shape of the house. And also I noticed that the windows of the house are all on the east and the west side of the building, so where the sun comes up and where it goes under. So then for the monthly climate data, we see that the temperatures are pretty mild. The winters do get quite cold, but the variations throughout the year are not very large. And also, I noticed that the red graph and the green graph of the temperature variations are not very far from each other, so the night cooling potential is also limited. And overall, Antwerp has a temperate maritime climate, and this is due to the close proximity to the North Sea.
It's limited, but you still have night cooling potential in the sense that your outdoor temperature in summer is still, well, 20 degrees or so, so it's still in the comfort range. So as soon as you have night temperatures which is lower than your daytime temperatures, and it's still sufficient to cool down, which is still the case, I would say. If you would have, for example, 40 degrees in daytime and 30 degrees in nighttime, it will not do a lot. While here it's still 20 degrees, which means you can reach comfort.
Okay. So for the comfort chart, we can see that most months fall under the comfort chart, so this would mean that you need direct solar radiation to be comfortable outside in the shade. And then we go to the more detailed hourly data, where we can see that, again, the winters are quite mild and we have cool summers, so no very large yearly variations. For the relative humidity, we have a relatively high humidity here in Belgium, and again, this is because we are close to the North Sea. And throughout the year, we have pretty consistent rainfalls, but our most wet months are October and November. Then we look at the solar radiation. So as we see in red is the direct solar radiation, so what we would have if there are no clouds. And then we have in green the diffuse solar radiation, so the radiation scattered by the clouds. And as we see, the proportion of the diffuse radiation is larger than the direct radiation, so we have a very cloudy climate. Here again, we look at the OA chart, and as I said before, most months are below the comfort zone, so meaning that we would need to use heating in the winter or direct solar radiation. For the winter month, I looked at January, and so this is a very cold month. The cloud of data is not very large, so the variations are limited. And then for August, we see that finally a few days are within the comfort zone, but the night is then outside of the comfort zone.
As you have lived in the house before, do you what's the experience? Was it often too hot in the house in summer, or is it okay?
Yeah, when I was a little girl, we didn't have any air conditioning or anything, and yeah, underneath the roof it got very hot. And in the winter also very cold. We would need to heat the house a lot. But now, yeah, we already took some measures to make sure that the temperature is okay inside.
But too hot only on the attic or in the whole house?
No, actually the downstairs area stays pretty cool.
Mm-hmm.
Yeah.
And that's, so if you maybe go back to the facade, just to have the picture again. So what you can see here is that as soon as you will start insulating the roof, you can avoid the overheating of the roof. Why is typically the roof warmer than in summertime than the below levels? It's because warm heat raises, so it means that if you heat up the spaces below, the warm air goes up. So, and typically you have the direct sun radiation because you have a perpendicular striking of the radiation beams to the roof, which it's normal that it heats up. So the only thing you can do to avoid active cooling is to well insulate your roof, which will also in winter be beneficial because then you have less heat. And so downstairs it's typically cooler because your window to wall ratio is quite limited. As soon as you would enlarge your windows, you will see that it will quicker heat up. So you actually protect your house or the indoor temperature by making sure that the windows are not too large. While of course in winter time you would need it because you want solar gains, but then you need kind of a system with, so here it's the old roller, I'm not sure how you call it in English, so the white, so on the left picture you see the open windows on the ground floor, while on the right picture you see that the white blinds are actually down. We typically do that in Belgium for winter, not for summer, but for winter because glazing is not well insulating and it feels really cold when you are near to that cold surface. So that's why we have these shutters for winter time. We actually don't use it so much for summertime, especially because in our old houses like that, built in 1879, the building is not insulated. You see that on the section on the right-hand side, it's just a full wall. So what you would need to do to make it comfortable and to reduce your heating demand is insulate it, the whole house and the envelope. But that would mean that in winter time your heat demand will be much lower, but in summertime you increase the risk of overheating. Because the problem is when you put insulation and you have solar gains, normally when it's not insulated building, all the gains, you lose them again through your envelope, but now they're stuck because you have an insulation layer. So then the solar shading devices become crucial. So what you will need to do is combine insulation with solar gains, but at the same time keep the sun out of the building in summertime, because then it will be really hard to cool it down again.
Okay, yeah. So in the winter we use the shutters to keep this, like the cold out, and then in the summer to keep the sun out.
Yeah.
Okay. I think we were here. And then also the wind analysis. So the main wind direction is from the southwest. And yeah, the highest wind speeds are around noon, but the wind speeds do stay quite moderate. I included this into the presentation because I noticed that the southwest, and especially the west side of the building, or actually the south side, sorry, is the only side of the house that doesn't have any windows. So the wind would not give any extra cooling to the building. And then for the architecture in Antwerp, most buildings are made from brick, and also roofs are often made quite steep because we have a lot of rainfall, and this is to shed the rainwater or even snow in the winter. And the roofs also tend to have overhangings, meaning that parts of the roof are sticking out to protect the sidewalls from frequent rains. Also, the windows are quite small and deep set, as you said, for the house that I am looking at. And then we use shutters to control the light and ventilation, but also to control the heat going in and out of the building. We have thick walls, which is also the case for the house that I'm looking at, which of course gives thermal mass. And a lot of the old buildings actually have, of course, fireplaces and chimneys to give extra warmth to the house. Also, the house that I was looking at had fireplaces in all the rooms. And then typical architecture is actually that we have very dense row houses, and these row houses don't need as much heating as an alone standing house. But the main reason that we have these dense row houses is due to urbanization and our very close population. The recommendations that I would recommend are the south facing windows for in the winter to capture the sunlight. Also compact design. So just as the house, it's very cube shaped, so we have a smaller area, but still a large volume. And then I also noticed that my own house has a raised foundation, so this is the ground floor is not at the same level as the ground floor outside, and this could be to protect against the water ingress. Thank you for your attention.
Thank you. Maybe one more remark. If you go back to the previous slide where you say we used to see in Belgium a lot of thick walls because of thermal mass. We actually didn't do that because of thermal mass, but we did that in the past because we had brick is our main material because it's a local material. But if you want to have a brick as a porous material, so when it's raining a lot, the rain just enters the brick. So we need to make our walls thick enough to make sure that the wet wall does not become, or that the wall doesn't become wet at the inside.
Okay.
And you can only achieve that by having sufficient thickness.
Okay.
So the strategy was not so much for thermal mass because you don't have a very hot climate. It could be used now, so you see that it works in churches or whatever, you indeed see it. But for housing, because of the small window to wall ratio, it wasn't really problematic to have overheating except for attics.
Yeah.
But then typically attics were not used. Now we use it because we want to use the space, but that was typically an empty area, so it didn't matter, it was too hot over there. So in that sense, it wasn't seen as important to make sure it's comfortable over there. But so the thermal mass had actually, or the thickness had nothing to do with thermal mass in the past. But it doesn't mean it's not a good strategy for now, especially when climate is changing and warming up. It could be an important one.
Yeah.
But that was not the intention originally.
Okay.
Yeah.
Okay, thank you.
Thank you very much. Yes.
Can I have a question about bricks and I'm first time in Belgium and I saw that there is a lot of mold because of humidity and I thought that bricks is also better material not to use plaster for the walls because the mold will be because a lot of new buildings with plaster in the mold.
Mm-hmm.
And actually another question is about in St. Petersburg is the same humidity and also marine climate because of the Baltic Sea near, but we haven't got this mold on our around the city, so on the concrete and on the plaster walls. So why is it like this?
So why do we? So the question is, here in the Belgian context, where we use a lot of brick, why do we use bricks, or why do we plaster them?
The thing is that on the bricks you haven't got mold because
No, we don't have typically.
yeah, but then it is a plaster, and if the building is new and painted, it is always the mold occurred on this.
Yes, but that's because it only occurs when they use a wrong plaster or a wrong paint. So what you typically see, let me check. So there are two types of walls. Let us first look at the original wall. So the thick wall, original buildings built without insulation. What happened is I'm going to take a section of a wall. So you had a brick, for example. Typically it's one, so if this is the length of a brick, let's say, so the typical wall thickness was the length of one brick, and then in the second layer you had two other bricks in the other direction, so let's say it like that, and then again this one. If you look like that, and you have a lot of rain, what happens? And the rain comes from that side, that's outside, you see that this becomes wet, because the stone is porous, so it indeed absorbs water. Now, if it's raining a long time, this will become more and more wet, and you will see that water will penetrate more and more inside. The only protection you have in this kind of walls is the cement mortar. So the only barrier you have, this is cement mortar, so all the joints are cement mortar. This is a barrier, so here the rain cannot penetrate. So to make a watertight wall with solid bricks, you actually need a wall thickness of at least 1.5 stones. So then you have like this, and then you have again this. Because if you have 1.5 stones, on each layer the water has a barrier, and it will never penetrate from the outside to the inside. That's in theory even, because if the constructor did not do his job well and some of these joints are not fully filled, you can still have a problem. So what happens then? Imagine you have an old wall and people won't have problems with moisture. What they sometimes do is put a plaster on this side as a protection against rain. It works well because it should be a watertight plaster then, or a watertight paint that works on one condition. It only works when it's watertight on the one hand, but it should be vapor open. As soon as it's vapor tight, you have a problem. Because in there can still become moisture from the inside. Because here you shower, you have your kitchen, people breathe, so there's still moisture coming in. And then it should get out in the two directions. Otherwise, the moisture will start to increase in the wall, and then you can really have problems. So you can cover it as soon as it's vapor open. As soon as you make it vapor tight, you will see problems. And it can be paint or it can be plaster, whatever, but it should be watertight but vapor open. If we have new, so we don't use this kind of walls anymore, because from an insulation point of view it's insufficient, so the UV or the heat resistance is too low. So we changed, and what we now do is we have on the one hand your inner layer of bricks, which are the large bricks, then we have an insulation layer typically, we have an air cavity, and then we have the facing bricks, let's say. That's how a typical wall is built up today. So we now have different layers instead of having one solid wall. And why did we move from that typology? This typology is more to have this insulation layer, otherwise we were losing too much heat, so it's a change we did in the 70s, it's more or less changed. But we still want to have bricks at the outside, because people like, visually, aesthetically, bricks in Belgium. We're really a brick culture, so we still want to have this, but these are still porous materials. So what's happening? These are becoming wet. And if it's raining a long time, it's becoming fully wet, and we get water drops at the inside. And that's why we have this air cavity. Because if we have an air cavity, what we do is, at the bottom, we kind of make something like this. This is a water barrier. So here we have a stone again, and here we have a stone. This is a watertight barrier. It's like a plastic foil. So if the water drops down, it's stopped here, it can't go deeper. And here, in this layer of bricks, we make openings. It's like the joints, we open the joints so that the water can run out again. And a second thing we do, at the top of the wall, the highest brick, we also make openings there. So some joints are left open, which means you get an air current in the cavity, making sure that if these bricks are wet because of long rain exposure, they dry better because of this air current. And the inside remains normally fully dry, because all the wet parts remain at the outside. And that's the reason why we have this cavity wall. If you plaster this, as you did here, it's possible, but then it needs to be vapor open again, watertight but vapor open. And then you normally should not have a problem. Is that an answer to your question, or is it another concern?
Yeah, but also the question is about in Belgium, in a lot of surfaces there is a mold or something like this. But in St. Petersburg we haven't got, but the climate is very similar. So why it is like this?
And it's concrete. You make your walls in concrete or in bricks?
No, just different types of materials compared to the Belgium, the same ones. We haven't got.
And you don't. You have the same moisture content, more or less. Wait, let me check it. So you are here, so it's quite moisture, so I don't understand then why you don't have mold. It should be the same.
Okay.
I don't see a reason, unless you have, no, but also the temperature are more or less the same. So if I look at Lily's presentation, and I put it next to it, I think it's quite similar, except for some more extreme temperatures, but I don't see a reason why you wouldn't have mold. The only thing is that if you heat things, the more you heat things, the less mold you have. Huh? So because your vapor, your dew point temperature, you avoid having condensation. But in general, at the because you're talking about the outside moisture, I don't see a reason. So if I now look at the two presentations or the two graphs, I think it's quite similar, so I don't see a reason why it would be different. So the only thing would be, it's just we see mold happening when walls cannot dry. So that's the only reason I can see would be raw material use. But if you use exactly the same materials and build-ups in the two climates, I don't see a reason why the behavior would be different.
I thought maybe it is because of the wind or direction or something, but...
Well, what we typically do in Belgium is that we protect our walls better in the wind directions, where you have wind and rain together. So that's why sometimes some facades have a cement mortar at the outside, just to make sure if the water pressure is too high, then you still could have problems. So that could be the reason. But I'm not sure if the winds is such a big difference between your case and ours. So we typically have southwestern winds, and then indeed that facade needs to be protected better against water. Yeah. But as long as materials can dry, you shouldn't see a problem. It's just when they cannot dry anymore that you typically see issues of flow. All right, thank you very much for your presentations, for your attendance today. So from next week onwards, I will not be here anymore. It is a colleague of me who will give the lessons on climate change. If you would have any questions on your presentations and you didn't get feedback today, let me know. I can have a look at it and answer your questions so that you can finish this part. So if I were you, I would try to finish this part and then we can start the new one next week. So I will try to finish it by next week.
Next week is a memorial week. How many lectures are...
We have lecture next week because we missed the first week, and that's on Thursday. We don't start in Alpha, we don't finish by the end of this semester.